next speaker is Neil Morgan from the Hartree Center. He will talk today about accelerating the adoption of data-centric and cognitive technologies.
Yeah, so good afternoon everyone. Just to introduce myself, my name is Neil Morgan and I'm part of the Hartree Center, responsible for the Future Technologies Programme at Hartree. I'm actually standing in for Robin Pinning, the CTO today, and I'm just going to be talking about a little bit of background about the Hartree Center and what we do, and also about how we're looking to accelerate the adoption of data-centric and cognitive technologies. So, the Hartree Center comes out of the 2011 Dominant Tilsley report, which identified that there were significant economic advantages in terms of driving the adoption of software and simulation within industry. That led to the funding of the Hartree Center in 2012, initially with a significant partnership with IBM as they focused on industrial engagement. That was followed up in 2014 by some additional funding to the tune of about £19 million, and this allowed us to broaden the remit of the centre to start to look at big data and energy efficient computing, an area that I've been previously involved in. But that's all been leading up to the 2015 investment, which was for £115 million, so quite a significant amount of investment from the UK government. And this is around a 5-year programme of R&D, again in collaboration with IBM, but very much focused around data-centric and cognitive computing, and how we can again drive the benefits of those technologies and evolving expertise into industry for economic benefit for the UK. And that's included embedding an IBM research group, so we have a significant number of IBM researchers who are now working alongside staff from the Hartree Centre, the Science and Technology Facilities Council, based at Daresbury. And what we're looking to do is extend our industrial and scientific reach and ultimately produce a set of digital assets, and digital assets can mean a number of things. It can be software in terms of tools, applications, middleware, but ultimately we're looking to do things like lower the barrier to adoption for HPC, big data analytics, machine learning and cognitive computing. So it's quite a broad portfolio. So the mission of the Hartree Centre is to transform UK competitiveness through the application of those technologies that I've just talked about. And we see real advantage and opportunity in leveraging the capabilities of hybrid cloud, whether it's on-premise or off-premise, to provide readily available and accessible services to industry. So we're looking to work closely with a range of partners, technology partners, academic partners, to undertake R&D, to develop prototypes, do proof of technology and proof of concept work that will ultimately lead to better products and services that are delivered faster and cheaper for our clients. So what's our focus? Well, our focus is around 3 main areas. For phases 1 and 2 is very much around consultancy, so working in traditional areas of HPC and big data analytics. As I've said, we've expanded that to energy efficiency as well, and starting to look at machine learning and cognitive computing. Very much the thrust for the work we're doing at the moment is around platform as a service. So again, this is where the cloud piece comes in. How can we develop the tools, the platforms, all of the capabilities that will enable users across the piece, both from industry and from academia, to leverage the capabilities available through cloud and address some of the opportunities and challenges that are there. And also undertake R&D, proof of technology. As I say, we're really looking to build this portfolio of digital assets and capability that will help to improve the UK economy. So, in terms of the focus of our R&D within the Hartree Centre, one of the things we've identified is a convergence of a number of different areas. So we see HPC, machine learning and artificial intelligence and big data analytics all coming together as part of much more complicated workflows. One of the challenges is how do we simplify those workflows and automate those workflows, and I'm going to talk a bit more about that as I work through the presentation. So there are three key themes that we've identified: convergence of data and compute, complex workflows and applications and architecture. And I'm going to go on to talk about those in a little bit more detail. So the convergence piece is very much around combining big data frameworks with HPC. So Spark is a good example, Hadoop, MapReduce, these sorts of frameworks which do facilitate ready data processing. How can we integrate those into the cloud and make those readily available and accessible so that you don't have to be an expert? Much of HPC and data analytics historically has been focused around, as I say, complex workflows where you're writing scripts, you need to understand the command line interface, etc. It's not really, it's an expert domain. We need to try and move away from that, give people the capabilities to use this technology to solve industrial problems. How do we deal with the issue of data? As some of the challenges we face grow, Peter's talked about this today, the size of the data sets that we have as well. How do we manage those? How do we process those? How do we do that efficiently, both in terms of computationally efficiently and energy efficiently? So we're looking at accelerated architectures. Gavin, the previous speaker, was talking about GPUs and Knight's Landing. But there's also hardware such as FPGAs, which we can use to reduce latency, increase throughput. The challenge there, of course, is how do we program those devices? It's not necessarily straightforward. So in terms of taking code and making them run on some of these new exciting architectures, there are big challenges there, and Hartree is looking to try and solve some of those in collaboration with our other partners. And sensitivity to the data as well, again, is a key one for our industrial clients, whether it's in the health sector or engineering, wherever it might be, whether it's Rolls-Royce or Unilever. Making sure that they can run their applications and their data is secure is extremely important. So workflow orchestration, this is one of the big areas of focus for Hartree as well. So we're really keen to develop new ways of enabling our users to more readily submit their jobs and applications. As I say, in the past it's been very complicated. You needed to be able to use Linux, use command line interfaces, pre-process data, scripting, etc. We need to start to build and design GUIs to make access to these capabilities and services much more straightforward, and as I say, lower the barrier to adoption. We want to automate as many of these processes as we can. Start to use machine learning to optimize as well, and ultimately, as I say, lower the barriers to use and adoption. And data locality and energy awareness has already been talked about in some of the other talks, but the whole automation piece is related here as well. So at Hartree we've done quite a bit of work around energy aware scheduling, how we can identify the most appropriate place to run a particular job, in terms of the overall energy, but also the runtime. So how do we do that and do that intelligently and make sure that the job runs in the most appropriate location? It's a really exciting time within HPC. We've already heard today about different architectures. There's an increasing array of architectures, but one of the challenges we have is how do we refactor and optimize some of the pre-existing scientific codes that are out there. Portability, extensibility, research software engineering, all things that you'll hear about, all very important for Hartree. Within the centre we have some work that's going on at the moment around research software engineering. We're looking to embed those principles within what we do within the centre. We're talking to EPSRC, who I know has funded some fellowships around research software engineering, so that's a key strand of what we're doing. Benchmarking and evaluation of these architectures is obviously key as well. We need to understand the capabilities of the hardware, we need to understand the requirements of the software and the applications. How do we best marry up the applications to the hardware? So again, we can run those applications in the most appropriate place, whether that's for overall performance, for energy, or whatever the client requirement might actually be. So there's a whole coordinated activity around benchmarking and evaluation. We have quite a long time scale around this. So whether it's Knight's Landing, which is just recently on the market, or looking into the future at other technologies, whether it's optical compute, whatever it might be. And collaboration and engaging with partners and other vendors is absolutely key. So I've already mentioned IBM. We're obviously doing quite a lot of work with Atos as well. We just purchased a new machine, a new production machine, which is I'll go on to talk about a bit more in the future. Hartree is very keen to try and influence the future of architectural design so that we can bring our benchmarking activities and our industrial engagement to bear and ultimately improve the EU bargaining position for future resources. Okay, thank you. So, in terms of our R&D output then, as I say, we're looking to produce a range of digital assets. These are the outputs which will effectively form products that we can then deliver to run across a range of these emerging architectures to try and automate and simplify workflows, and ultimately looking to deploy services, HPC and deep learning as services in the cloud. So just in terms of some of our machines then, Hartree is quite unique in some ways because we have quite a broad range of architectures. The latest addition to the machines that we have at Hartree is the Scaffold pipe machine. This is a Soprano architecture machine. I'll let Andy talk about that in a bit more detail. It's probably part of his talk. But it includes Intel Xeon processors and night landing, a total of 3.4 petaflops. We're also going to host the Oxford Jade system at the Hartree Centre. This is a Bull DGX1. We have 2 Power 8 systems as part of the IBM collaboration. The latest machine is a Paragon machine, which includes the NVIDIA P100 GPUs. We do some work with ARM as well, and through Lenovo and Cavium. We have what we think is probably, well, currently anyway, the largest ARM 64-based supercomputer in the country, which is actually close to 2,500 cores, and a range of other more standard architectures as well. Okay, thank you for listening.